What's going on, Principles of Engineering class? This is Mr. Suffren, and I wanted to share with you what we covered in class today and pick up where we left off. So today in class, we calculated the external member forces of our truss. We have a 7-member truss with 5 joints and 1 load. And in class, we found the magnitude and the direction of our external forces. So our external force, RBY, we found the magnitude of 150 pounds, and it is going in the negative Y direction, and we notated our summary sheet. We found the magnitude of our reaction force X is at a magnitude of 100 pounds, and RCX is the direction of RCX of that force is going in the negative X direction. And we found the magnitude of RCY, the reaction force RCY, and the magnitude is 150 pounds, and the direction of that force is traveling in the positive Y direction. And of course, force 1 at 100 pounds was given to us, okay? So what we're going to do, we're going to segue to calculating the internal member forces. And we have calculated some today, but we're going to tackle all of this. And as you know, well, let's just go through the our check sheet first, okay? So in calculating the internal truss member forces, first we have to draw a new free body diagram, in which we have done. Without drawing any members, draw and label the joints in their proper locations. We've done that. Outline or highlight the location of the truss members. We have done that. Draw all of the external forces acting on the truss. We have done that. Now here's where we are right now. Draw force vectors to show what's happening inside the truss members. Determine which direction you think the truss members need to push or pull to keep each joint in static equilibrium. Identify and label if each truss member is in tension or compression. Okay, so again, what I typically like to do is I like to look at each joint and determine how the internal forces are reacting to each joint relative to or responding to the external forces that's being applied on the truss. However, so that's what I like to do, but however, in the method of joints, you would draw everything in tension, okay? Again, in the method of joints, you would draw everything in tension. So remember, when something is being stretched, okay? So when something is being stretched, that object that's being stretched will respond by pulling inward. Therefore, at each joint, every dot or joint, you would draw an arrow pointing inward, okay? So that's the method of joints, and that's what we're going to do right now. And then, once we have everything drawn in tension, we're going to let the math determine if the internal force is in fact in tension, or we need to change the direction arrow and make our internal force in compression. And the way you tell if your prediction is incorrect with regards to the direction of your internal force, in your math, if you get a negative answer, that means you need to change the direction of your arrow. Okay, so let's do it. So what I'm going to do, I'm going to take my red pen, and at each joint, I am going to draw each joint in tension. Okay. All right, so each joint is in tension, and I'm going to name these joints. These forces. I'm going to name the forces. So, and there we have it. Okay, so we're going to call this force right here. Did I name? Okay, since this is truss member CE, we're going to name this force right here force CE. This is force CE. Okay. Since this member is DE, we're going to call this force DE. This force is called DE. Okay. Since this force is called, this is between joint C and D, we're going to call this force CD. Okay. This force is called force BC. This is force BC. And this is force AB. This is force AD. Okay? All right. And in my next video, I'm going to continue on, and we're going to start calculating each joint, finding the force for each joint, starting with joint E.